Hello, OPM 2000. This is my second take trying to do the video. The first time I forgot the microphone. Minor detail. Anyway, I do apologize. I yesterday came and went and I forgot to do the video. So I deeply apologize. However, here it is, the long awaited for OPM 2000 video coming directly to you here today. Um, so this is week 8 of our class. This is the halfway point. This is where we get into forecasting. Now, forecasting, it's how we predict things that are going to happen in the future. You see forecasting used in economics. It's used in meteorology, which is different than metrology. Meteorology is the weather. Metrology is a study and science of measurements. Um, we see forecasting used in operations management. Okay. And that's what you're going to be dealing with primarily this week. Now, we can use our gut intuition, and there are types of forecasting that do that, but we can also use mathematical algorithms and equations and data. And it's essential that we know where we've been at, what has occurred, to understand why we are where we are now, so we best can predict where we're going to go to in the future. Now, this is also something that's used in decision making. Now, we're going to get into something here, and it's called uncertainty. Uncertainty is a constant. We live in an uncertain universe. Chaos is and will happen. As a matter of fact, it is so predictable that the ratio between chaotic event to chaotic event, it falls in what's called um, the Feigenbaum constant. Okay, it's 4.66 and the number keeps on going. And that doesn't mean we can predict exactly when the chaos, the uncertainty is going to happen, but we know that the ratio keeps getting smaller and smaller between the points of instability. So that means it's happening more frequently. So we can use it in forecasting to understand, listen, we had 3 months in between points of uncertainty on our production line. This next time, I bet it's going to be less than 3 months. And after that, I bet it's going to be less than 3 months. Now, why is that? That's because every time we hit what's called the bifurcation point, and I'd have to draw you out a graph here, but if you have your X and Y axes and you start with a line and it's going up and it hits a point of uncertainty, that's chaos. We denote that with a kind of a jagged squiggly line. Okay. After that, there's two possible paths that come, and they go along until they hit a point of bifurcation. They hit that squiggly line, that chaos, that uncertainty, and they bifurcate. Now, the space in between uncertainty to uncertainty, that's that ratio, that Feigenbaum constant. It's a universal constant. Whether it's a far off, distant pulsar emitting magnetic radiation, or whether it's your dripping faucet, or problems on an operations line, or things that occur in your personal life or relationships, scientists have been able to show everything falls under this universal constant, the Feigenbaum constant. Now, why am I telling you that? That's because every given moment of time, we are affected by a multitude of variables. If I alone try to understand them, I'll get some of them, but I will miss most of them. If I have a team of 100 people, we'll get more of them, but we'll still miss quite a few. If I have a team of 12 million people, we'll get a lot of them, but we're going to miss still a significant amount. That's because there's so many possible alternatives that could occur. If you're familiar with nonlinear dynamical systems theory, that's the fancy way of saying chaos theory. You know, the moth flapping its wings causes a hurricane to occur across the planet, that sort of thing. Now, this is true. Not that a moth causes a hurricane, but the small, insignificant things in our lives, in our work, in our production lines can have the greatest effect. We know this as the bullwhip effect, and you're going to be learning about that this week. Small fluctuations in the supply chain have great consequences later on. There's also the Cobra effect. The Cobra effect is I implement a policy to take care of a problem, but it creates the same problem I was trying to get rid of to begin with. The Cobra effect. It comes from colonial India, of all places. There was an increase in Cobra bites. So the provisional British government, they said, we are going to enact this policy. You bring us a dead cobra, we're going to give you money for it. So they put a bounty on dead cobras. People started raising cobras. Once the British government figured out people were raising cobras just to kill them and bring the bodies to them to get the money, they said this policy is bad. So all these cobra farmers released their live cobras into the wild, and now there's an even greater problem than there was before with cobra bites. Now, you might say that's interesting, but how does that apply to us? Well, you're on a production line, you create a policy to fix a problem, but it actually creates a bigger problem in the future. And this is, we go into the law of unintended consequences. The law of unintended consequences is intimately paired with the Cobra effect. And all of this falls under uncertainty. If I can try to understand as many of these variables affecting this moment of time in my decision making process or my forecasting process, then I'm able to make better decisions. I'm better able to forecast more accurately. But I have to understand I'm not going to get every one of these variables figured out. I'm not going to catch them all. Even with a million people, I'm not going to get them all. So we account for that. We account for that in our forecast. All right. So this week is kind of an interesting week. It's one that I actually really enjoy. I enjoy this concept because we deal into uncertainty, and that goes into systems theory, goes into complexity theory. Those aren't things you have to worry about in the material. It's just things as me as an academic, as a researcher, I get excited about. Um, yes, I am a bit of a nerd, but that's okay. You should know this by now. Um, anyway, I hope that you have a great, wonderful week. Let's see what we have for you to do this week. Let me get to the right. Here we go. This is our week. You have a discussion. The initial post is due Wednesday. You do have replies for that post. You have to reply to at least two of your classmates, and that is due by Sunday. Outside of that, I'm not seeing. Let me go back a screen here. I don't want to give you bad information. Yeah, that is this week. So you've had 2 weeks of math. Now we are on to week 8. You have the discussion. The additional reading that you have in the modules, operations 11 and 12, I highly recommend that you read them. I know that the module says to read them, but sometimes I still have students that don't. If you don't read this, you're not going to be able to do well in this class. Remember, use APA 7 for all references and citations in your assignments and in your discussions. If you use information from a source, and I'll know because you guys are what, sophomores in college. So if you're talking about things that I, as Dr. Gagnon, studied in grad school, I'm pretty confident it's not common knowledge for you. I'll know that it's not that you need to be citing it. Plus, I know the material that you're reading. So if you use material, cite it. Reference it and cite it. APA 7 requires both references, and every reference must have the corresponding citations. And you don't put a citation just at the end of the paragraph. You use it, you include a citation in every sentence that you use material from that source in. Okay? Have a great week, and I will see you in the funny pages, as they say.